Hello, sir. Shall we start now, sir?
Yes, we can start. If you're ready, you can start. Yes.
Hello, everyone. Present here virtually. I am Preeti here, and I welcome you all for today's session, which is titled as Recent Advance in Artificial Intelligence and Deep Learning. And presenting this session, we have with us our today's expert, Dr. Pukuluri Kiran Shri, sir. Dr. Pukuluri Kiran Shri sir has received his BTech and ME in Computer Science and Engineering from JNTU and Anna University, respectively. He has obtained his PhD degree in the area of Artificial Intelligence from JNTU, Hyderabad. He has authored 6 textbooks for undergraduation and post-graduation students of engineering in AI and published more than 100 plus research articles in various international journals and conferences. He has filed and published 6 patents in his area of deep learning and AI. He has got 18 plus years of teaching experience and working as a professor in the Department of CSE at Sri Vishnu Engineering College for Women, Bhimvaram. He has associated with various journals and associated with a conference in various capacity as an editor-in-chief, editor members and reviewer. He is a global vice president of WSA, World Statistical Data Analysis and Research Association. Without wasting much time, I am welcome to Dr. Pukuluri Kiran Shri, sir. You may start now, sir.
Thank you very much, madam. And it's a privilege to be part of this research circle. And I have seen just now, like the way in which you are organizing the webinars, it will be useful for the research community. And whatever talk I have planned is as per the textbook that I have written on recent advances in deep learning for Pearson education. Most of the discussion was part of that actually. So the title is very apt because recently, if you see, the Gartner has released the top 10 promising technologies that can disrupt the world. And the one technology that can disrupt the world is artificial intelligence. If you see the list that was listed by Gartner, we could easily find out artificial intelligence is there in the top 1. And top 2, you have cyber security and machine learning. And then cloud computing, various other things are there. So obviously, we are living in a world of artificial intelligence. Indirectly, this AI is an integral part of our life. So the basic idea of this webinar is to give insights on people who wish to work in artificial intelligence, indirectly to create some research ambience in artificial intelligence and deep learning. And this is how I have planned the sessions actually. Yes, this is how I have planned. I will just let you know what are the various mechanisms of deep learning and artificial intelligence. And we'll think about various applications. We'll discuss about various applications of artificial intelligence deep learning, which will definitely help us to create. Did my slide is changing, man? Yes, I think it is now changed. So I will talk about various applications of artificial intelligence and deep learning. Then we'll see what exactly is the difference between deep learning and artificial intelligence. And then we'll see why we need to go for machine learning and what is the reason that we need to shift to deep learning. And then we'll see a case study also. So if you see the basic nomenclature that when we try to design systems, what is that we will tell people is, can we design a system which thinks exactly as a human being is a difficult objective to achieve. So we cannot design a system which thinks exactly like a human being. It's very difficult objective to achieve. And the second objective that is achievable is, can we design a system which acts like a human being? Can we train a system which acts like a human being? Can we design systems? So obviously, this is an objective that can be achievable, and most of your today's expert systems will fall into this category, acting human being. Whether it is a Sophia or a Mycin, all these are parts of these expert systems. So the third interesting future of the things is like, can you design a system which thinks rationally? Which thinks rationally means without any training, can we have a system which thinks logically? It's very difficult objective, but to some extent with the proper training, we can design a system. But acting rationally, can we design a system which acts logically when trained? Is a possible objective. So most of the expert systems that are designed in artificial intelligence and deep learning will fall into these two categories. Some of them will fall in both of them, like Sophia, which is a humanoid robot, which will fall in both of the categories, acting rationally and acting humanly. We have many examples, and we have many standalone systems, which we call it as an expert systems. So this is possible, and people who aspire or who wish to perform the research in the areas of artificial intelligence and deep learning, they can aim, can we design a system where we need, when people ask me about AI, I will say, can some of the activities that are done by a human being can be done by a system? We call it as an AI system. If a system exhibits intelligence, we call it as an AI system. Do you have any system which proposes or which solves NP hard problems? We can call it as an AI system. But we have a theoretical concept called as super AI. Can you design a system which thinks beyond the perception of a human being? Is called as a super AI. It's very difficult objective to achieve. So now I will just see various examples of artificial intelligence. Like I kept a old system called as the Deep Blue, which is meant to play a chess game here. And I have kept a advanced system called as the Tesla, where the technology that was used is deep learning to the extent of 50%. So Deep Blue is a system that was designed that exhibits AI, which has defeated Gary Kasparov in late 1990s. But what is that you need to understand from Deep Blue or any AI system is like, you have a traditional game called as tic-tac-toe game where two people will play this game in a 3x3 matrix. So when somebody like A starts playing the game and B wish to hinder the winning possibility of A, and as so I'm just talking about various games I am talking about systems that exhibits intelligence. We have here that we are discussing about a deep learning mechanism where this Deep Blue is a system that has defeated Gary Kasparov in late 90s. But what is that I'm just trying to tell is, you have a game called as a tic-tac-toe game, where this tic-tac-toe game was played by two people. And once A starts here, I assume that B played here. then what will happen is B has to keep here to hinder the winning of A, and A has to keep here. Then until unless so you play the game in such a way that A wins the game or B has to win the game, or somewhere like they have to go for a tie. But what is the most important thing is like how can we predict the moves of the opponent, and what are the possible ways in which I can win? What are the possible ways the opponent can win? What are the possible ways the entire game can go for a draw? This is vital. This is very important also. So in this context, we need to find out like you have a deep blue system with 64 squares, that is 8 by 8 matrix, and 16 items here and other item, 16 items there, and every item has its own specific movement. Like a soldier can move in the terms of way in which it was defined. An elephant can move from one place to other place where the movement of elephant is defined. So how can we predict the movement of the opponent is very important in this context. So a system which exhibits intelligence, we call it as an AI system. So does this system is exhibiting intelligence or not? Yes. If you see the implementation of Deep Blue, what is that we are doing is we try to predict the movement of B with respect to A. Like A makes a move, and we wish to find out what are the possible moves that B can make. And based on the movements of B, I will predict the movements of A. Based on the movements of A, I predict the movements of B. Slowly, what is that we do is we wish to finalize an equation where I can build a predictor. So if somebody asks me what is the outcome of your entire theme of artificial intelligence is to build a predictor, you have the data, and then based on the data that you have, you try to build a classifier which can predict what will happen in future. This is what AI does. So here we have seen a Tesla. A Tesla is a company which builds semi-automated cars or self-driven cars, where the agenda of this motivation of the car is like when it's moving from one state to other state, it has to depend upon the left neighbor, right neighbor, front and back neighbors. And how can we design a system which can perceive the environment? How can it understand and process the voice online? How can it process the video online? It is specialty of the system. So I wish to tell you, like, if you wish to design an AI system, which is very important, is how can we process a video live? How can we process an image live? And all these are very important and vital features of an AI system. Earlier, when we were trying to design an AI system in 2001, 2, 3, we wish to type something and the system can understand something and reply. But now we have AI systems which can process voice and interacting with people with voice. And now we have AI systems which are interacting with people in the terms of video. So a Tesla is a system which processes video online. A Tesla is a system which processes audio online. And as if you see the various features of Tesla cars, they can go for they have cruise control. They have a facility called as self-parking. So how much space is there and how much space is needed to park this vehicle. And all these are features of an AI system. So you need to have an AI system which can process video at real time, which can process at after how much distance is the nearest neighbor is with respect to the left, right, and the straight and back neighbors. So it is like a cellular automata, which will think about the left neighbor, right neighbor, back neighbor, and all other neighbors which are when it is moving from one state to other state. So based on the Google map, It will start and go to the destination. In between, how can it perceive the environment? How can it process the voice? How can it process all these things? Is a vital factor for Tesla. So again, the same nomenclature I have followed. I have kept a very old version of artificial intelligence called as Mycin, and I have kept advanced humanoid robot called as Sophia here. And we have something called as a Mycin, which is a old expert system, but we have almost 128 different types of versions of Mycin are available, because earlier when people tried to invent Mycin, the Mycin is an expert system which takes some symptoms and it will try to give what are the diseases that are attributed to that Mycin, to that symptoms. It gives symptoms and it gives some diseases that are attributed to that set of symptoms. But now Mycin, how it was trained is it is if it has the profile of the candidate and it has the history, it is trying to predict what type of diseases that are prone in future. What type of diseases that are prone in future based on the profile that they have, the history of diseases that he had in earlier. So it is going to predict something in future. Now the Mycin has went to the extent that it is trying to identify the protein coding regions and promoter regions to predict whether a patient is prone to cancer or not. What type of cancer? Is it a bone cancer or a breast cancer or a blood cancer? And now if you see the latest version of Mycin, we could also find like Mycin can process the x-rays of patients and it can find out whether he is prone to COVID or not. So you have a lot of applications in this particular Mycin, and we can discuss a lot about Mycin, because Mycin is the oldest expert system which is updating every day in the terms of functionality that is serving to the people. And Mycin, if you see, it can also help suggest the doctors to prescribe medicines without any side effect. That's what the most important thing is. Without side effects also, we can prescribe medicines. That is what now the Mycin is doing. And if you have 6 fingers in the hand, what is the reason for having 6 fingers? If you are suffering with chronic diseases, what is the reason for you to do that? And all these things, you can have a system called Mycin which can help you. Now, if you come to the Sophia, Sophia is a humanoid robot where you need to think that Sophia is an AI system which can interact with people. And now Sophia is taking classes for 8th class students in mathematics, and it is interacting. And even if you see the Sophia, it can analyze and find the sarcastic laugh of the students. But what is the interesting fact is how can Sophia can process videos at live and can just tell what is a sarcastic laugh and what is not. And how can it understand the language, colloquial language of the students, and it can reply. And how can it solve the problems online is very important. So people who are aspiring to work in this particular artificial intelligence, they need to understand how can you design a system to process audio, how can you design a system to process video, and how can you design a system to process a text. So Sophia is a humanoid robot where it can give gestures, it can laugh, it can talk, it can understand the language that was tried, it can take classes. It can also understand the sarcastic laugh. So it is a system which processes video, it processes audio. And how can it understand the native and colloquial languages? This is a matter of question. Like we have various systems in deep learning to process images. We can take CNN to process what is sequential data. We can go for RNN, or you can go for a LSTM. So many systems are there. So what system is needed for for what type of requirement is also very important. So what is that inference that we wish to tell in the terms of two slides that we have referred is, if you design an AI system, we need to understand how I have a system which can process video. I have a system which can process audio. I have a system which can process text. So this is very important, and these are the normal applications of artificial intelligence. Like you can say, this is this we are talking about Hawkeye. Hawkeye can Is my voice is audible, sir?
Yes, sir.
My PPT is visible?
Yes, sir. Your
Yes,
presentation is.
because I just log in with other system. Thank you for staying. And what is it we are discussing is when we try to have an AI application, what must be there is we need to have a system which process video, we need to have a system which process audio, we need to have a system which process the image as well as text. So we are talking about a AI system where we call it as a Hawkeye, where it will be used in cricket, where it's very difficult objective to achieve, like how do you process a video and predict what type of deviation it will take after pitching, and what is the height that it can travel after pitching is a very difficult objective that is to be achieved. And this is a system like which is built on 50% of deep learning, which can predict the displacement and deviation of the ball once it was pitched. And the next application that I have quoted here is face recognition. And we are using this face recognition everywhere, whether you go for a Twitter or a Facebook or any other prominent application. Earlier, we used to use MATLAB for recognizing the faces. Now we are using Python, because if somebody asks me what are the languages that are pertaining to artificial intelligence, I can say Python, or and even to some extent we can call also MATLAB as an A language. Before that, we used to call a language called as Prolog as an A language. Everywhere I can give an image to a Google and say find out what are the similar faces that are pertaining to this. And this slide I have kept it intentionally. The reason is that most of the artificial intelligence systems, whether it is a Siri or Alexa or Google Home, what people are doing is like they're interacting with the systems in the terms of voice. So the usability and dependability of the system is getting increased when we process an audio. So that is the reason. Hello. So we have various systems. We have various systems which can process audio. We have various systems which process video. Just a minute. Various systems which will interact with people in the terms of audio, video, and we also have many systems which process colloquial language. I have kept here a drone system which try to take images of the crops, and it will try to compare the images with the healthy images, and it will try to find out whether this crop is diseased or how much time it will take to get the fertility. And even we are using drones to sow the fertilizer also. Indirectly, these drones are monitoring the crops, what type of diseases that are prone to these crops in future, in how many days the fertility of the crops, where it can give the yield. And it will also just alert the people like whether they're prone to disease, what type of diseases that are prone. On all these things, we have drone technology that are used now. We have many advantages that we have for drones. So I have kept Google Chrome here, like when we wish to travel from Bhimvaram to Delhi, what is the shortest path based on various conditions, not only weather conditions, the conditions of the traffic, the conditions of the roads. Based on that, you will try to suggest. And this Google Home can be claimed as an AI application. And IBM Watson is a question and answer mechanism where I asked IBM Watson a query with respect to the health informatics. It searches the database and it will answer intelligently. And if you see the definition of artificial intelligence, AI systems when integrated with a smart home, like everywhere when we have an AI system integrated with IoT chip, that we can call it as a smart system. And these are the traditional AI systems that I have kept. Weather prediction is a traditional system. See, I have the data of weather variations for 1 year of area pertaining to Delhi. Then I can say I can predict what type of weather this Delhi will have in July. But you have some parameters called as dynamic parameters that will affect, that is called as humidity, precipitation, the distance between your earth to the nearest cloud. If you consider all these parameters, we can predict the weather better than what when we process the history. Like we have statistical data, that is data pertaining to a particular place for the last year or last 10 years or 20 years. That data we need to have, because machine learning algorithms or neural network algorithms or deep learning algorithms can only work when you have a data that is called as a database. That is a fact. But apart from the static data that we have, we need to also have dynamic data called as data that will changes with respect to time. See, the precipitation amount will change with respect to time. What is the climate of Delhi at 1 o'clock today will have an impact between the distance between the nearest cloud and earth. If the distance is less, there is a possibility to have a rain. So weather prediction has very different types of outcomes like rainfall, wind speed, and the temperature, and so on and so forth. So weather prediction, even we have many expert systems that addresses this weather prediction. But we need to understand, when we design an AI system, we need to process both static parameters as well as dynamic parameters. The same way we have something called as stock market prediction, where I have the history of prediction. Like I wish to predict what will be the stock market price of Reliance. If I have the history of this Reliance price for the last 1 month, I can predict what type of stock market price that Reliance will have based on the closing price or something like that. But the stock market prediction has will be also affected with respect to the dynamic parameters. Like you have a news saying that Reliance is going to have outlets in and around South India as well as North India. The stock market price will change. You have a fake news saying that Reliance is going to close in some areas, the stock market price will change. You have a forum called as Yahoo Forum, where based on the discussions that they have in Yahoo Forum, the stock market will change. So assume that there is a war between India and some other country, the stock market price will change. All these are dynamic parameters that directly or indirectly affect the stock market value. So my interest of keeping all these things is, like, you have static data and you also have dynamic parameters. When we process both of them only, we can have a robust AI system. And if you, I spoke about IBM Watson in the last slide, you will have a crowd counting systems. Like, how can you process a video live and tell how many people are there in that video, and what are the people who are having abnormal actions that can damage the infrastructure. Is called as crowd counting systems. But we need to understand, when we are implementing AI, what is it we try to do is, we try to design a system which process video, and it will tell you how many people are there in that video. And we try to predict what are the people and what type of people are having abnormal actions, And a like a CC system is a deep learning system which process video and tell you how many people are there. Or based on the training, it will tell you how many people are having abnormal action that can damage the infrastructure. That so that the respective person, like the administrative people, will be elected based on the automatic processing of the videos. This is what very important is. So you process videos online, but it is automated procedure. So you have many systems that I said about Mycin has a functionality now to process X-rays and tell you what type of people are prone to COVID in future. If you see the X-rays and say that what is the difference between the X-ray and what are these healthy X-rays and disease X-rays. And we have a Vishnu Society where almost we have 656 employees are there. So I wish to find out how many employees are crossing social distancing norm. I can have a systems, almost 76 systems are there, which can process videos and tell us how many employees are processing this, following this norm or not, like social distancing. And I wish to find out how many people in my enterprise are having masks or not, and whether these masks are kept properly or not. We have a systems. We have almost 254 systems, which will tell us whether how many employees are having masks or not, processing the videos, and how many employees wear the mask properly. Also, we can analyze. So all these are AI systems which predict something in future. This is shopping everywhere when you use Amazon or Flipkart. We have systems called as box over, which will predict what type of goods that a customer will procure in future based on the history of the way in which this customer is procuring things. And particularly not only in shopping, in everywhere, like I'm just searching, trying to procure printers last week. And everywhere where I use when I open a Facebook or LinkedIn, this suggestions for this printer is coming. The reason is how can we process the history or profile of a candidate or of a user and try to predict what type of customs or what type of goods that he wish to procure in future. This is where we need to apply artificial intelligence. In 2018, the government of India has started giving this e-challan mechanism, automated procedure, where in national highways, you have CCTVs augmented with speed guns. Whenever a car or a vehicle exceeds the amount of speed that has to be, and whenever that happens, the speed gun excites or ignites this.
200 around 12 p.m.
What does your speed gun will do is this system will take the video of that car or system or truck. From that video, it will extract images. From that image, it will extract the car number. From that car number, it will give an automated email saying that this is what the speed that was exceeded in this particular place, and this is the amount of challan that we need to pay. So this is an e-challan mechanism. This is an automated procedure. It is an example of an AI system, and we have chatbots everywhere. If you just try to open an account, obviously we have chatbots that will interact with people. How can I use an account? How can I take a loan? All these are the functionalities of chatbot. And now if you see the top 10 promising technology that can disrupt the world by Gartner, we have something called as RPA, robotic process automation, where many companies are preparing bot for mundane tasks. You can talk about a company called as UiPath. You can talk about Automation Anywhere, or you can talk about Blue Prism. All these companies, they are working on designing bots for mundane tasks. And artificial intelligence is everywhere, particularly in health sector. And we have AI in navigation sector. I said about the Google Maps. So what is that I wish to say, conclude with respect to the application that I have mentioned here is If you wish to design an AI system, you need to find out what type of mechanisms are there to process text, what type of mechanisms are there to process video, whatever mechanisms are there to process images, how can AI understand the colloquial language and all this. That is the reason I have all the slides which will enable or which will tell you like to create a research ambience. So when you take a traditional system and AI system, your traditional system thinks about what is the input and write an algorithm to get the output. But in AI system, you know what exactly is the input, you know what exactly the output will come. You try to design a model which will fit into this. So that is the reason we have several data sets. So we try to have a system. For this input, we will have to get this output. So we try to design a model which will fit for this set of inputs and set of outputs. So we have seen the definitions of artificial intelligence, machine learning, and deep learning. So if you wish to implement artificial intelligence, we can implement by using machine learning or neural networks or deep learning. But when the data sets are more and the features to identify, see, if somebody asks me, I have given 10 images. In this 10, if somebody asks me what are animals and what are human beings, it's very easy to identify the differences between human beings and animals. Or if somebody gave 100 images, if somebody asked me to differentiate the vehicles and human beings, it's very easy to differentiate. But if somebody gave 2 lakh images and tried to find out what are human beings and what are animals, even if we wish to find out what type of animal it is, then the number of features to identify the animals, whether it is a cat or rat or bat, it's very difficult. In the human beings, if somebody asks me how many are men or how many are women, the number of features to identify these men and women will be more. And the number of data sets are more. Then we need to go for deep learning. We call it as deep neural network. So we have many mechanisms in machine learning. When the data is labeled, we go for supervised learning. When the data is unlabeled, we go for unsupervised learning. When we proceed from one step to other step based on the feedback that was given, we call it as reinforced learning. I said about a lot of drawbacks of machine learning where we cannot apply machine learning, because machine learning suffers with the way in which you store something in your system. So these are the various ways in which various standard algorithms where you can go for supervised learning, like you have a nonlinear data and we can go for support vector machine. These are various mechanisms where when the data is unlabeled, we go for unsupervised learning. And this is the most of the time I will tell, like when the data is more, most of the machine learning algorithms, the performance is static. It is like a plateau like this. It is very static and it is 60, 60, 60, that's what. But in most of the deep learning algorithms, when the amount of data is more, you will get a better performance like this. There is an improvement in the performance. That is the reason when the data is more and the number of features to identify things are more, then go for a deep learning. That's what in general we say. That is not a rule, but this is how it is. So we have various deep learning models. It can be RNN, recurrent neural network, where I can use this when I have sequential data, when I process natural language processing statements. I can use CNN when we have many images and videos. LSTM is an extension of recurrent neural networks. When you have, when I wish to complete compare things, I have to go for LSTM. Our GRU is lesser than RNN. And what is that I wish to tell you is we have various mechanisms in deep learning, and all these things are very static. And now we are talking about TNN, Terra Neural Network, which is an energy efficient neural network. So many things are there, but what is you need to do is what type of data you have, whether it is labeled or not, and whether you need to design a system to process video or audio or images or a text. That is also very important. We can choose an appropriate model based on your input. So these are the references that I have referred, because I have not cited the images. I have kept this disclaimer because all this are only meant for educational purpose. And I have to thank the research circle, and I have to thank all the initiatives of this research circle, because a lot of free webinars they are doing, and they are keeping all the things in their channel. So I have to thank them for giving this opportunity. The next time when I meet this type of webinar, I wish to give some hands-on sessions very freely for the people who wish to develop deep learning models in future. Now, if you have any queries, please unmute yourself and we can have a discussion. And in between, I have a small power failure. That is the reason I've just shifted the system from one system to other system. Pardon me for that. And if you have any queries or interaction, you can just try to interact, or you can have you can have my email, and you can just try to send an email if you have further queries, because I have worked in two DST projects of what 36 lakhs, and other one is for 2 lakhs on various aspects of deep learning, and I have written a textbook on deep learning for Pearson education. Most probably that will be out by the month of not later than August, where you can find all the stuff that I have discussed. So thank you very much.
Thank you so much, sir, for this very nice session.
Please.
If anyone has any question, you can ask. I think no one have any questions, sir.
Nice.
Thank you so much, all the participants, for your active participation. Let me inform to all that this complete session will be available on our Research Circle YouTube channel. So if you want to watch it again or want to share it to somebody, so please do visit the Research Circle YouTube channel. Thanks. And last but not the least, thank you, Dr. Kiran Shri sir, for taking out the time for today's session. With your permission, I would like to end today's session here, sir.
Thank you, madam. Thank you very much.